So here's my progress, March 2022 for number theory 2. I already had chapter 4 from last year, and I put it in here because it didn't fit that other book for number theory 1. So technically, I've already shown all of this. I'm pretty sure I showed this because I used it for the image for my YouTube channel. And then since then, I have almost completed chapter 5 problems. So I have all of chapter 5 notes, okay? And this is really kind of like it's got a couple of small topics, round robin tournaments, it's got the infinite calendar, it's got hashing functions, which I really like. I want to do a lot more hashing functions. I think it's very interesting given that I work in information technology. I dig it. So I'm going to do more. And then there was also, after that, there was check digits, which is in Gallian chapter 0, which is one of the reasons why I ended up doing all this stuff in number theory, is because I wanted to read Gallian abstract algebra, and chapter 0 had a lot of number theory, including check digits, and I was like, okay, I gotta go learn this stuff better somewhere else and then come back to it in Gallian, which I'll get to, I'm sure, years from now. And then chapter 5 problems. Okay, I've done a whole bunch of them. And yeah, I believe I did finish chapter 5 problems. And so I think pretty soon I'm going to start working on chapter 6 problems. Yeah, some check digit problems. And then I've got the lectures for chapter 6, which I'm not done with. So I think I have somewhere else a few problems for chapter 6 that I must have started or I'm about to. I forget. But that's where I'm at. I've almost finished taking notes for chapter 6 for Matt's little theorem. Is one of the big parts of this chapter. There it is for Matt's little theorem. A to the p minus 1 is congruent to 1 mod p. P is not divisible by A. A is an integer. So that's for Matt's little theorem. Very interesting. Some cool problems, I'm sure. I was trying to follow one of the examples and in Rosen, and I wish Rosen went more basic for me, but that's okay. I really like the hard problems too. So there was a problem in Rosen, let me see if I can find it, where the answer was, where was it? Let me see if I can remember. There was an example in Rosen, and I was like, what? And I was like, because I always doubt Rosen to see if there's an error. But then I said, let me check it out. Let me figure out how to do this problem. And Rosen had explained how to do it earlier, but I found the person in YouTube who explained it really, really well. I'm trying to find it. I should have thought about it before. Let me see. This example 610. One of these problems ended, Rosen just casually says, well, you can check this. And I was like, what? How'd you get that? And I looked it up. I looked up how to do them, went back, and then I actually worked out the problem in detail. And let me see. I'm trying to find where Rosen did it, and I was like, wait a minute, what's going on here? 8. Oh, it was this one right here. Yeah. So was it? No, it was. There was a problem where the last one looked simple, and I was like, how do you get that? And so I went and I looked it up in YouTube, and I solved an example, and then I figured out how to do it. It's the whole thing about constantly squaring Yeah. I should have thought about looking through this more carefully before talking about it in a video. But yeah, so I went and I worked out the numbers. Oh, there it is. There it is. Okay, here it goes. So I'm reading and I'm like, oh, because 5 to the 280 is congruent to 67 month 561. And I was like, what? How do you get that? And so yeah, I went in through YouTube and found examples, really understood how the problem was done, and then I went and I worked it out. I worked it out until I got the answer. And then I did a few more. I was like, all right, now that I know how to get 67, okay, then I did a whole bunch of problems. So yeah, here, and then yeah, I did a whole bunch of problems just to understand how you take some gigantic number and you figure out by constantly squaring, right? 3 to the 2, 3 to the 4, 3 to the 8, 3 to the 16, 32, and then you combine them all, and then you get the answer. And sure enough, I went back and I took what Rosen had done, that example, and I worked it out. Very important for me to do that. So I felt very proud that I could do that using examples from YouTube. So that's my progress so far in chapter 6 of Rosen. And that is proofs 2.